Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue Dave's Defect with a discussion of roll interweaving on certain winders that run slit rolls side by side. This is a very costly defect because every occurrence means the loss of not just one, but two finished rolls. I know your time is precious, so let's get started. We will define interweaving as when adjacent rolls do not separate after winding. There are many aliases for this defect in the plants, including run-togethers and stuck rolls. However, a picture may help. The top figure shows 5 wound rolls with a separation. The bottom figure shows 2 of the rolls with not only no separation, they are actually overlapped above the core. This problem is common where slit rolls are wound side by side. This is where the duplex winders have a big advantage because every other roll is wound on a separate shaft and thus cannot interweave. This problem is one of the more difficult winding problems to troubleshoot. One reason is that there is no single root cause. In fact, there are many ways that this can happen, and all relate to path control in some way. We will study path control in great detail in my award-winning and trademark Web201 that has been taken by 5,000 people. We'll also introduce the subject in the next clip. Sometimes the problem is with the very first wrap not being applied squarely to the core. Sometimes it is with poor mechanicals, such as misalignment of a drum, lay-on roller, and/or chucks. Sometimes it is caused by poor tension control, especially if tension falls off, say during a speed change. The thing to note, however, is once the adjacent lanes overlap or cross, even for a moment, the problem may become self-exciting because the crossing lanes make a bulge, a diametral bulge there, and that bulge, as we learn in Web 101, tends to pull material sideways towards it. In short, the paths may only cross for a few seconds, but the results could last for a few minutes. Some very important tools to creating a small separation between the rolls is effective spreading. This includes the pre-slitter spreaders, which improve roll width tolerance and roll edge roughness. The post-slitter spreader is even more useful to keep lanes separate, but only if they are well applied and well maintained. Again, if you are not super familiar with these subjects, you really should go to school. However, spreaders cannot solve all problems. Here is a checklist of what you might reasonably expect of an effective spreading system. However, as we learned in our Web 101 class, there are certain problems related to interweaving that the spreader cannot solve, even if the spreader is well applied and well maintained. We already mentioned one, that is, poor tail to core squareness during the thread. This slide shows another one related to baggy webs and how to diagnose that particular cause. Others still include poor mechanicals and poor control, design, and maintenance. If we use the free and easy Roysum Library Database Search Tool by Abbott App, we will find at least 100 articles on various aspects of spreading. However, I am not aware of even one that directly addresses role interweaving during winding. One reason is that there are so many mechanisms to generate the path control issues that underlie the problem, and that would be quite a writing challenge. In the next clip, we will outline 5 ways that the web can move sideways. Until then, we can always use the first principles of the sciences of web handling, coupled with creative problem-solving techniques to figure out which one mechanism dominates on your winder. Thank you so very much for joining me in this defect solving and defect preventing series. Stay tuned for the next clip where we will discuss web path control problems. If you found anything interesting or useful here, please like and share and subscribe. Also, please consider supporting the work of this channel using the Patreon link below. See you next time.